So for 3 and 4, we were just supposed to graph. So let's identify a so A, H. What's A for number 3? 1. What is H? And what is K? -1. So our first point would be at 3, -4. The way that we would find any remaining points would be to use transformations. There's a couple ways I could teach this. I could teach you to put all the transformations in one, and then therefore you could now just then count points, from the origin. But when I tried to do that the first semester, that didn't go over too well. So I've kind of gone to what the other teachers teach, which is just to teach you how to transform using A and leave H and K out of the transformation. But then the difference is once you go to count, you have to count from the vertex, not from the origin. So the way you do that is say, all right, let's see what's going to happen 1 to the right, and let's see what's going to happen 2 to the right. What's 1 squared? 1. But then that 1 needs to be multiplied by A, but the thing here is that A is also 1. So what's 2 squared? 4. So we end up going 1 to the right, 1 up, 2 to the right, 4 up. Just understand this method only works if you're going to count from the vertex. So if I go to the vertex and I go 1 to the right and 1 up, I put a point. Go 2 to the right, go 4 up, put a point. Then I can use my axis of symmetry to find the rest of the points. If I reflect this point over, I just flip it over 1 unit on the other side. I go to the point that's up here on the x-axis, flip it over 2 units on the other side. Parabola. The next one here. What's A here? -1. What do we expect to see then if when A is negative? The parabola is going to face down. Okay. What's H here? -4. What's K? 0. So I'll put my vertex at -4, 0. But then when it comes time to do, I'm still going to go to the right, but now let's figure out what to do up and down. 1 squared is +1, but I have to multiply it now by -1. What is 1 times -1? -1. So this is telling me that from the vertex, go 1 to the right and then go 1 down. 2 squared is +4, but then times -1 is -4. So from this vertex, I would go 1 to the right, 1 down, and then 2 to the right, and 4 down. Draw axis of symmetry. Then flip the points over. This first point is 1 away, so I do like a mirror, and I put a point 1 away. This next one is 2 away, so I go 2 away on the other side, and all the children rejoice because they're upside down parabola. Did we even get to do number 1 on the second page? No, we didn't do that one. All right, so here they want us to state the transformations and then write the equation of the function. Okay. There's a more the issue here is how to find A. But there's a more algebraic approach you can take to finding A. But let me see if I can explain it to you just a little simpler, just counting way. The stating of the transformations and the writing of the equation are going to both, again, depend on A, H, and K. And of the three, what are the two easiest to find? H and K, sure, but that's just the vertex. Here's my H and K. Eventually for number 2, there's H and K. There's H and K. That's real simple. You can just tell by looking at it. But how you find A, there's more than one way to do it. I tend to favor a more algebraic approach, but you want to try one that way and see if you guys can. You don't like algebra? You like this way. Yeah, you know what? Let's do it the algebraic way. And then if you don't like it, then we can do it the different way. I think I might confuse you also. Anyways, what's the H and the K? Let's knock that out. Get that out of the way. Well, 2 and then 4. Yeah, H is 2 and then K is 4. Would anybody disagree with that? All right. So here's how you would find A. Let's see what else. Okay. On the very first page of the notes, you have the formula for vertex 1. Okay, which says right up here, y is equal to a x minus h squared plus a. In any equation in algebra, if you want to solve and get a number for a variable, for an unknown, that can be the only unknown. So if I'm looking for A, for that letter, what would I have to be able to put numbers in for? H and K, obviously, but what else? Y and X. And so I need 4 numbers I have to put in. The H and K is obvious. I already found H and K. That's 2 and 4. Excuse me. But I need numbers for X and Y. What can I use for X and Y? Any other point that's on the graph, you just can't use H and K again. Because you already used H and K for the vertex. You can use any other point that's there. Sometimes it's a little hard. Like I always like it when they make it easier for you and they kind of like highlight a point so you can tell it's on there. Sometimes it's a little blurry. But is there another point that we can tell that's on there for sure? You say 5 and what? On this graph, 5, 1? 1
and 5,
1. Okay, you can say 1 and 5. Yeah, it looks like 1 and 5. Nakai says 3 and 5. Okay. Now, see, I know because I've done this before that when the next point is like 1 to the right and 1 up, that A is going to end up being 1. But let's just prove it algebraically. Ready? So let's use for X and Y. Remember, you can use any other point, and they're all going to give you the same answer. Some people told me 1 and 5. Some people told me 3 and 5. Some people might even tell me it looks like 4 and 8 is there. They're all going to give you the same answer. We'll do what Martha says. We always want to do what Martha says. Which one do you want to use, Martha? 1 and 5. X is 1, Y is 5. All right, let's substitute that. So instead of putting a Y, what do you think I'm going to write? Instead of, because since Y is 5, I'm going to write 5 equals. Okay, then I'm going to write the A that I'm looking for, parentheses. Instead of X, what am I going to write? 1, because we said that X was 1. That's the one that Martha picked. Have I lost anybody so far? Okay, minus H. So what am I going to put instead of H? 2 minus 2. Don't forget the square. Some people, even some of my better students, sometimes forget to write the square. And it's like a silly mistake, but we don't want to do that. and then plus the k, which would be plus 4. What's the only letter you see? What's the only variable? We only see the a, correct. So now we could solve. What's 1 minus 2? Negative 1, good. Squared plus 4. What's negative 1 squared? 1. What's 1a? 1. What? 1a. What is 1a? Just a. So this whole little mess here just becomes a. So 5 equals a plus 4. If I just do minus 4 on both sides, what does a give you? A is 1. So I want to be able to save time to do this little activity that we have, the second half. So I'm not going to write all this down. Plus, you have more space. You can write it down. So I've already found A, H, and K, which is the important thing. Do you guys still write that? Anybody still writing? I don't have enough space. Let's state the transformations. It'll be on the video, but I'm not going to write it. I don't have that much space. With that A, H, and K, what's happening here on this function? Is there an x-axis reflection? No, because A is not negative. Is there a stretch or compress? No, because A is 1. Is there a translation? Yeah, there's 2 of them. What are the 2 translations? 2 to the right, translation 2 units to the right, and 4 units up. Okay, now how would you, remember the second part says write the equation. That part I will do. How do you write the equation? Well, now we go back, instead of writing x as 1 and y as 5, we go back to writing regular x's and y's. We would write y equals, sometimes they'll write f of x equals, that's fine also. Instead of an a, I'm supposed to write a 1, but that 1 is supposed to go outside of a parentheses. When there's a 1 outside of a parentheses, you don't need to write it. So I'm just going to write the parentheses. We'll know that the 1 is there. We write the x again. If h is 2, I would write minus 2. And again, we don't want to forget the square. And then plus 4. Was that too hard for you guys, or were you able to handle that? It's not too much algebra. Let's see if we can do the next one. Here, why don't you guys do that one? See if you can do that one on your own. Let me know what you end up getting for the, just give me the equation. At the very end, you already did it, didn't you? You got it too? What'd you get? Yeah, give me the, I want the equation. Yeah.
Y equals 3 x minus 2 squared.
Okay. So he wrote y equals 3x minus 2 squared. How do you know just by looking at it that's wrong? There we go. All right. And how do you know that that's going to be negative? It's going down. So we can agree by looking at this that h is going to be 2 and k is 1. That's the vertex. But how do we find a? Well, I just showed you how to find it algebraically. Here, I guess I could try the oversimplification one thing and see if that makes sense to you. But it's not going to work all the time. But and you know what? I need to talk to the other algebra ones just to see how they teach it. But I'm guessing what they're doing is saying, all right, an easier way to find a is just look at what happens 1 unit to the right. Like up here, how we were talking about what happens 1 to the right and then 2 to the right. Well, the easy one is just look at what happens one to the right. So if I go one to the right of the vertex, what else am I doing in order to stay on the parabola? I'm going 3 down. That 3 down is going to be whatever A is. Whatever happens 1 unit to the right, that's what A ends up being. But if you were to find it algebraically, you should end up with the same. Look at this next one, A, H, and K. H is 1, K is -2. So then if you wanted to take the easy way out, if I go 1 to the right, what else am I doing? I'm going up 2. So with that, if I were to write the equation y equals, then I would write the 2 first, parentheses, x minus 1 is minus h squared. One thing I forgot to do with the second one, state the transformations. Let's go back to number 2. What transformations are happening with number 2? Huh? Okay, so you would write x-axis reflection for number 2. You have to write x-axis reflection. What else is happening on number 2? What type of by a factor of what? Yeah, we're stretching by a factor of 3 because that's what A does. And then there's still 2 translations. Where are we translating? 2 to the right and 1 up. Yeah. So there's 4 total transformations. For number 3, what transformations are we doing? Yeah, we're stretching by a factor of 2. There's no reflection, and then we're also translating where? Right to the right 1 and down 2. Excellent. Let's see. Let's do these last 4. Here, all we have to do is write the equation. Oh, they're giving us a description, so let's use this description to identify A, H, and K. If I'm doing a vertical compression of 1/2, what value does that attribute to? What's going to be 1/2? A. It doesn't mention a reflection, so it stays positive. If I'm going to go 6 units to the right, what does that mean? H is 6. Good. If I'm going to go down 2 units, what does that mean? K is -2. So now when we substitute y equals 1/2, parentheses x minus 6. Remember that for h, you got to change the sign when you put it into the equation. Squared minus 2. If you have any questions, raise your hand. Don't be afraid. The only mean one here is Ann. Ann is the only mean. Just kidding. Kiara's means too. Somebody want to give me number 2? You did it already, Caleb? Oh, and you got some competition. What'd you get, Caleb?
A equals -1.
Say it again?
A equals -1.
No, but I want the equation though.
Oh, y equals -1.
Okay, but we're not gonna write the 1. That'd be silly.
Negative, and then parentheses x minus 3.
Huh?
Or plus 3, because yeah, and then square.
So for number 2, A is -1. Since we're going to the left 3, H is -3, and since nothing is mentioned about up or down, K is 0. So when you substitute that in, anytime A is -1, you need the negative, but you don't need the 1. For the H, you change the sign. You gotta put +3. And then since there's no K, there's no adding or subtracting on the outside. Huyen. Did I say that right? Huyen. Okay. You help me out with number 3. sorry. Okay, say that again. Okay, good. Yeah, vertical stretch of 6, A at 6. Good. To the right 4, yes. Very good. Up 3, positive 3. If I substitute that in, that would be y equals 6. X minus 4 squared plus 3. That's something different, let me know. And then the Kai, why don't you take us home? Give me A, H, K. Good, because of the reflection and a compression, A is going to be negative 1/2. Excellent. H would be good, 0, yeah, because there's no left or right. And then K is? Yeah. Okay, here's an interesting one. Y equals, when H is 0, what don't we need? Parentheses is good. Negative 1/2 of x squared minus 1. When there's no H, there's no need for parentheses. So now this is an activity that all the algebra ones are doing. In the first 2 days, exactly what everybody else is doing. So I can plan accordingly. So it's pretty quick. It's a little math. You're not gonna turn it in or anything. Okay, so if you look at the back page for you, there's 12 graphs here, and for each graph, they want us to state which is the equation and which is the description that matches. If you look at the other pages, the other pages have the graph, the description, and the equations. So we're gonna match these up. So let's start off with graph 1. Okay, so you go to the page that shows you a picture of graph 1, and we for graph 1, let's identify. Let's see our A, H, and K. So what does it look like H is there? 4, yeah, because the vertex is 4 units to the right. What does K look like there? -5, I would say. And then the A, this is why I like to do these things algebraically, because the A, you can't even really tell. You cannot, it cannot be directly next to it. It wouldn't be a parabola. We just don't know how much it's gone up. Let's just leave A right now as a question mark. At the very least, what do we know about A though, just by looking at it? Yeah, we know that A is positive because the parabola is facing up. Correct? All right. So let's go to these. Do we see any of these that have a vertex at 4, -5 and would be an upward facing parabola? Yeah. Is there any other one that it could possibly be? No, because even though this one here, E, looks like it, on E, the H is actually -4, not +4. So I can go ahead then and cross out EF. I've already used it. Now let's look at the description. Now because we maxed it, they kind of helped us out, and now we know that A is 1/3. So that's going to help us with the description. When A is 1/3, we're doing a compression of 1/3. There's no reflection, but then there's a translation that's going 4 to the right and 5 down. Yeah, it does look like, yeah. Yeah, they don't give you the factor of the compression, but yeah, it would have. No, it can't be 5 because 5 is left 4. The 10, yeah, Roman numeral 10. Vertical compression right flat. That's like 10. Let's look at number 2. It looks here like A might be 1, but it's hard to tell on these diagrams. What is a little easier to tell is the vertex. The vertex here appears to be at 0, -5, if you agree with me. And it looks like A is going to be 1, because it looks like if you go to the right one, you go up 1. But it's hard to be completely sure. But what do we definitely know about A? It has to be positive. A has to be positive because the parabola is facing up. So, do any of these equations have a vertex at 0, -5 with an upward facing parabola? Yeah, it has to be A. The only one. Because remember, when H is 0, there's no parentheses. And the only other one that doesn't have a parentheses is G, but G doesn't have a K either. So it would have to be A. And then for the description, just down 5. Because when I went back to look at the one I matched, yeah, the A there, it ended up being that the A was 1. That the number in front of the stretch is just a 1. We're right about that. So A, and then let's see what the numerals. Okay, graph 3. It looks like the A could be like a -1, but we don't know for sure, but we at least know it's negative. And then it looks like H and K are the origin. 0, 0. So we're looking for something with a negative in front with no parentheses and no adding or subtracting. Yeah, that one looks like G. And if it indeed is G, then yeah, it looks like that was a -1 in front. So here, G. And how about for the description? We reflect it over the x-axis, yep, and that's it. Which teacher were you with before, Caleb?
I went to UT last semester.
Okay.
But before that, I was with.
Okay. Good, man. 4. We don't know for sure what if there's a stretch or compressed there. It looks like it might be stretched. It looks a little taller and skinnier, maybe like a stretch of 2, but we're not 100%, and we don't want to do the whole algebra involved, and this is a matching activity. So, but the one thing we know about it is that it's negative. That we know for sure. And it looks like the vertex is at -2 and 4. So let's look at our when any of these have a vertex at -2 and 4 that's facing down. Did I count wrong? It looks like a 4 to me, man. 3? Is it just because my thing is off? Oh, you mean it's number 3?
Oh, no. I mean,
No, because that dot, that's like right there. It's like on the line.
Ah, that's what it is. Good. Guys. Okay, yeah, what he's saying is that these first dots are the actual origin. I mean, the axis. Yeah, and on the other ones, it didn't throw me off because those were the low. It didn't come into play. But yes, okay, good. So it's 3 of them. So K should then be not 4. K should be 3. So let's go back. Which of these have a vertex at -2, 3? Facing down with potentially a stretch, yeah, B. And it does look like from the equation that it was that A was -2. You're keeping track at home. And which one has the reflection, the stretch of 2? Well, and they don't tell you what the stretch is, but and then we're going left 2 and up 3. It is 6. You guys want to see if you can finish up on your own? If I give you like I don't know, 1 minute each. Even less than that. So about 7 or 8 minutes. See if you can finish up on your own, and then we'll do it together. You finished or not yet? Okay. Give you a couple more minutes and then we'll do it together. All right. I'm just gonna keep going and then you can, if you're still finishing up, you can finish up and we'll match up later. Okay, the fifth graph, we can tell it's facing up, so we know A is gonna be positive. It also looks kind of skinny, so it looks like it's gonna be a stretch. It looks like it was like, squished horizontally, but stretched tall and skinny. So it looks like A is gonna be bigger than 1. And then H is 0 and K is -4. So we're looking for a vertical stretch and then a vertex at 0 and -4. Because H is 0, there should be no parentheses. And I'm not, did I do something wrong? Oh, there it is over there. I. So should have got an I for this one. And then when we go look, these should get easier also because the more that you take away, now there's less options. Vertical stretch down 4, 7, right? And it looks like from the equation that the stretch was by a factor of 5. That stretched out by a factor of 5. So here A was 5. Yeah. The number thing is another one?
Number 3 was
Wasn't it 7?
number 3. Roman numeral 4.
It was 7.
The graph
Oh, I got you. Is that what you're saying, Jada? Sorry, thank you. Okay, so graph 6. Okay, this is still facing up. It doesn't look that much skinnier. If anything, it looks compressed. You can tell because here, when you go to the right, you're not even going up a full box. So it looks like some type of compression, but we know that A is still going to be positive. The H is 1, 2, 3, 4. I'm counting 4 to the left. And the K is 1, 2, 3, 5 down. So 4 to the left and 5 5 down would have to be what, E? And it is confirmed there was a compression there of 2/5, so it's going to be E along with section stretch. Uh, 4? No, section. Vertical compression at 5. We said what, E5? Seven. Okay, we know that this is going to be downward facing, so we know that A is going to be negative something. It also looks compressed, because if you look at the vertex, and you look at the first box to the right, it's not even making it down there. So it looks like it's going to be a compression. So we're going to have to find out how much. Let's look at H and K. 2 to the right, and we don't count this one 4 up, 2, 4. J, right? And that's weird. Like, what's different about J than maybe some of the other ones we've seen? It's got a decimal. But we said for a compression, the number, the magnitude of it, like, not forget about the sign. The sign just means it got flipped. But the magnitude is less than 1. Well, obviously, 0.2, even though it's not a fraction, is still less than 1. So there was a compression there. This one looks like it was negative 0.2. And which one has that? Nakai says 4. To the right 2 and up 4. J4. Okay. 5 left. This one looks it looks a little skinny. So there might be a stretch. It's hard to tell with the graph, but we know it's positive. H is 1. It looks like it's just 1 to the right, and then 3 down. And the C, right? C?
Okay.
K? You saying K? Yeah, C. Yeah, because of the sign. Remember, this is going to be a negative 1. When you see a plus there, H is negative 1. So I would say C, and there was a bit of a stretch, because A is 7/4. 7/4, even though it's a fraction, is greater than 1. So yeah, it looks like there was a bit of a stretch. It is a little skinnier. So C, and then which one has a stretch? 12 vertical stretch, right? 1 down 3. Right, 1 down. Yeah, very good. 12. So C. Okay, 9. 9 is very similar. It looks to be about the same type of stretch, but the only difference is they went to the left one. So I know H is negative 1, K is negative 3. So this is probably the one that you were getting confused with. And then I know A is positive, I just don't know by how much. This is going to be the K one. And this is also a stretch. It's a little bit of a smaller stretch. It's hard to tell by looking at the picture, but 5/4 is greater than 1. So it's K, okay, 3, so K3. K number 10. Here this is H is negative 1, equals 5, k is 2, and we know that a is negative. Looks like it might be skinnier, but so we're gonna go with, what is it,
D.
okay, you say D, we went up. Yeah, negative 5 and 2 here. D and H look a little similar as far as the vertex goes, but since we went up instead of down, it is gonna be D. And 2. 2 left. This one here, it's hard to tell because it's small, but like there's not a lot of it inside the viewing window. But this one doesn't really look stretched or compressed. It might be, never know. But we can tell it's facing down, so A is negative. And then 1, 2, 3, 4, 5 to the left, and then 2 down. So that's gonna have to be H. So H goes with 11 sounds good. And then by process of elimination, L that was left, right? What does L go with? 9. Fun. Keep your eyes out this weekend on the E-class page. I'll post next week's assignment if you want to get a head start on it. I'll send a remind message to go to that Romero Algebra 1. Even if you were in my class before, you have to still do it because that's another thing I have to wipe out completely. So if you're gonna sign up for remind, then I'll let you know when I post it.